Hello Algebra 2 standard students. I am going to make another video here to help us to understand more of what is required for this upcoming test. And that's going to be tomorrow for block 2 and on Tuesday. Tomorrow for block 5, Tuesday for block 7. Alright? So I trust God you will guide us and you will give us insight and good understanding that each of us will do our best and nothing less in Jesus' name. I'm going to start with number 5. It says, for each of the following quadratic equations, find the following. A, the axis of symmetry. B, the vertex. C, the y-intercept. And D, a reflected point. And E, this should be E right here. Got two D's. Let me change that. This should be E. To graph the function. Okay, so this is quite a lot to do, but it will deepen your understanding of quadratic functions. First of all, look at this one. F of x equals 2x squared minus 4x plus 5. Can you tell whether or not this opens up or down? Looking at it, the number before the x squared is positive. It's a positive 2, so on. Opens up. So already we have an idea which way it's going to go, up. So let's go ahead and take it by bite-sized pieces. Now the first thing is the axis of symmetry. Axis of symmetry, that is, it's a line and it's x equal to negative b over 2a. So let's take a look at it and identify our A, B, and C. A would be 2. B would be what? Trust you'll be able to tell. B would be not 4, but negative 4. Finally, C would be the 5. So that's the first thing to do, to identify your A, B, and C. Okay? And while I'm looking at it, right off the bat, the easiest one of these questions to answer would be the y-intercept. The y-intercept is always the constant term which doesn't have a variable beside it. So if you want, we can already go there. Y-intercept is part C. So the y-intercept is going to be the y value when x is 0. So when x is 0, y will be 5. So that one we can do very, very quickly. If you just visualize 0 being here, 0 times negative 4 makes this 0. 0 instead of the x here would be 0 squared times 2, that would be 0. So all that would be left would be y equals 5 because f of x is y, right? So that's done. Alright, let's come back now to our axis of symmetry. This is the formula for the axis of symmetry, negative b over 2a. So you've got to remember that. Say that with me. The axis of symmetry is negative b over 2a. Okay, axis of symmetry is negative b over 2a. So here we go. Negative, and the b itself is negative 4. So you put that in there. That's the b over 2a. That's going to be 2 times a, and a itself is 2, positive 2 that is. So upstairs on the numerator we're going to have a minus negative 4, which would be a positive 4. And downstairs 2 times 2 would be 4. So axis of symmetry is, this is going to be equal to 1, as you know. Please don't write 1, because you're going to lose points for that. It's x equal to 1, because it's a line. X equal to 1, that's the axis of symmetry. Okay, so that's done, axis of symmetry. And now we turn our attention to the vertex. Say, well, what's the difference? The vertex has an x coordinate, which is the same as the axis of symmetry, and then it has a y coordinate. So, in thinking about the vertex, the x coordinate of the vertex is going to be 1, and all we have to do now is to find the y coordinate of the vertex. X coordinate is 1. So you say, how do you do that? Well, we go to the equation which says f of x, or y. F of x is y is equal to 2x squared minus 4x plus 5. Wherever you see x, you put 1, because 1 is the x coordinate of the vertex. So we go and we say f, wherever we see x, we put 1. We're going to do that all the way through now to work out what the y coordinate of the axis of the vertex will be. It's going to be 2 times 1, that is squared, and then minus 4 times 1, minus 4 times 1, and finally plus 5, plus 5. So in working this out, we get 1 squared, which should be 1, times 2, so 2. And here negative 4 times positive 1 would be what? Negative 4. Finally, plus 5. Plus 5. So putting this all together, we get 2 minus 4 is negative 2. Negative 2 plus 5 gives me what? Positive 3. So 3 is the y coordinate of the vertex. What I'd like you to do is, when you're done, or that you have these answers I'm giving you, just go back and work it yourself. Just go back and work it yourself and confirm that you know how to do it. So that's done. We got the vertex, and the vertex is a point which has an x coordinate and a y coordinate. The x coordinate is the same as the x value for the axis of symmetry. Now what is left? Well, we already got the y-intercept, which is 0, 5, and finally we have to find a reflective point. So I'll show you that when we do the graph, what the reflective point is. So let's go ahead and do the graph. And we start the graph with the vertex at 1, 3. So here I go. 1, 2, 3, 4, 5. It's going to do 5. And then 1, 2, 3, 4. Let's say 5 here. This is 1. This is 1. So here comes the vertex, 1, 3. So 1, 1, 2, 3. The vertex should be right here. Okay, that's the vertex. I'll just put it in like this. 1, 3. From there, we can do the y-intercept. Y-intercept is at 0, 5. 0, 1, 2, 3, 4, 5. So the y-intercept right here. So here we go. 0, 5. And now I'm going to show you the reflected point. Well, let's go ahead and graph this half first. Here's the vertex. On this graph, it looks something like this. Now it's a parabola. So that would be half of it. You say, well, I don't quite get this. Now look carefully. The axis of symmetry is the line that goes right through the middle of it. It's the line x equals 1. That's why it's so important, because it goes through the heart of it. So x equals 1 is right here, this line. So I'm going to give it a dashed line. Maybe I can find it here. Let's see if I can find it to make it a little bit nicer. Yeah, maybe right here. Axis of symmetry right here. X equals 1 everywhere here. So this is the axis of symmetry, this dashed line. And here comes the reflected point. This axis of symmetry is a mirror that will reflect the y-intercept over on this side. So the intercepted point will be as far to the right of the axis of symmetry as the y-intercept is to the left. The y-intercept is 1 unit over here, so the reflected point will be 1 unit over here. So it's going to be right here. That's a reflected point. I can darken it a little bit. Again, it's the mirror image of the intercepted point of the y-intercept right here. So this will give me a guide for drawing the right half of the parabola like this. And this reflected point, what is going to be the coordinates? Well, it's going to be 1 unit to the right of the axis of symmetry and 5 units up, just like the y-intercept. So what's this going to be? 1, 2, and then 5 up. So it's going to be 2, 5. So that would be the end of it, 2, 5. Alright, so you have to just go over this step by step, replay it if you need to, so you know how to do this. Alright, let's take a look at number 6. It says find the zeros of each quadratic function by factoring. Alright, let me do, let's do this one. The zeros. What are zeros? Zeros are x values that would make y to be equal to 0. So since this is f of x or y, we're looking for the x values that would make this to be 0. So listen carefully now. We're going to factor this quadratic equation, x squared plus 9x plus 20, into 2 binomials. And the way to do this is we look for 2 numbers. You have to go back to your notes and look at this. You look at for 2 numbers which when you multiply them you get 20, when you add them you get 9. Again, 2 numbers which when you multiply them you get 20, such that when you add them you get 9. What are those numbers? 4 and 5, right? So it's x plus 4 and the other binomial will be x plus 5. So that's how you get the factors. And for this to be equal to 0, remember you're multiplying 2 things together to get 0. Either one has to be 0 or the other has to be 0. So how can this be 0? How can x plus 4 be 0? If x is negative 4, because negative 4 plus 4 would be 0. So you say x would have to be negative 4. That's one answer. And the other one, how can this be 0? For x plus 5 to be 0, then what? X has to be negative 5. Okay?